Okay, so this is skill 8, and I started off by choosing 4 integers a, b, c, and d, and these are my two functions, f of x and g of x. First, f of x is 4 inverse of cosine of 7 in parentheses x minus 5 minus pi over 8, and I drew that out here. And the parent function of that is inverse cosine of x, which I drew here. And to find the domain and range of f of x, I found domain and range of the parent function and then performed transformations on them, like these transformations, to get the domain and range of this cosine graph. So first, the domain of the parent function was -1, 1, and the range is 0, pi. So after performing a horizontal dilation by a factor of 7, the domain is -1/7 to +1/7, and the range is still 0 to pi. After doing a vertical dilation by a factor of 4, the domain is still -1/7 to +1/7, and the range is now 0 to 4 pi. And these are all in brackets because everything is being included. And then a horizontal shift to the right by 5 causes the domain to now be 34/7 to 36/7 because I added 5. And range stays the same, it's 0 to 4 pi. And then a vertical shift down pi over 8 causes the domain, the domain here is still 34/7 to 36/7, and the range is now negative pi over 8 to 31 pi over 8 because I just subtracted pi over 8. So yeah, that's the domain and range of this cosine graph here. And g of x is 4 inverse of secant of 7 in parentheses x minus 5 minus pi over 8, and I drew this out here. And the parent function of this is inverse secant of x, which I drew here. So again, I found the domain and range of this parent function and did transformations on them to get the domain and range of this secant graph here. So the domain of the parent function is -infinity to -1 union 1 to +infinity, and this is a parentheses, bracket, parentheses, because you're including -1 and 1, as you can see. I drew that on the graph. And the range is, this time the bracket is here, so bracket 0 to pi over 2, parentheses, union, parentheses, pi over 2 to pi, bracket, and these are parentheses because it's like, this is the asymptote here. So again, I did a horizontal dilation by a factor of 7, and so the domain is -infinity to -1/7 union 1/7 to +infinity, and then range is still the same as that of the parent function. And then after a vertical dilation by a factor of 4 again, same as the above graph, the domain is still the same as this, and the range is now 0 to 2 pi union 2 pi to 4 pi. And a horizontal shift to the right by 5 makes the domain -infinity to 34/7 union 36/7 to +infinity. And the range of this is the same as this one, the one right above it. And lastly, a vertical shift down by pi over 8. The domain is the same as this one, and that's like the final domain of this secant graph. But the range is now negative pi over 8 to 15 pi over 8 union 15 pi over 8 to 31 pi over 8. Because I just subtracted pi over 8 from this, just like I did above here. So yeah, this is the domain and range of this secant graph, g of x here. And the domain of f of x, which is 34/7 to 36/7, is excluded. It's not included here in the domain of g of x because g of x this is the domain of g of x, as you can see, and 34/7 and 36/7 are like, they meet. They both have that point there, like both graphs have a point at 34/7, 36/7, but g of x has nothing in between it. So yeah, like the max of this graph is the same as the max of this graph, and the min are the same, but like f of x has something like between the max and the min, but this one just like goes away from that. So yeah. And then the range of f of x, which is negative pi over 8 to 31 pi over 8, it's like the same as the range of g of x, because it's also going from negative pi over 8 to 31 pi over 8. But g of x, as you can see, has an asymptote at 15 pi over 8, which is like right here, because one side of the graph is going to negative infinity on the x, and then this side is going to the other way. So yeah, there's an asymptote here where it like never meets. And yeah, that's my skill 8.